So guys, today we're going to start day 6, which is factoring special polynomials. Now there's two types that we're going to do. The first type is called the perfect square, and the second type is called the difference of squares. Okay, so make sure before you start, you just give a quick highlight to numbers 1 and 2 here. This is the goal for today. We're going to be factoring trinomials using a perfect square method. So this is only true for certain trinomials that have a nice factoring where the length and the width are the same. And then we're going to be doing binomials of the form a squared minus b squared. Okay, and I have that picture demonstrated for you at the top. So for day 6, we're just going to start right at the top using this picture here. And I want you to think back to the area of the polygons. The area will be, remember, it's always length times width. So for the top part of this rectangle, which is actually a square, because the length and the width are the same, you can see here it's x plus y. So the length is x plus y, and the width is also x plus y. Can you visualize that on this diagram? Positive x, positive y, and positive x, positive y. So this is not a rectangle, it's a square. So now what I want you to do is do like we do with the area diagrams. You have the first column times the first row. X times x is x squared. So if you were to FOIL this out, and you can do this on the side, if you prefer the foiling better, x times x is x squared. Now you have to go the first column times the second row. X times y is xy. Good. That will be this one here. Now you have to switch from the first term to the second term. Now you have to distribute the second term. So that means now we're on the second column times the first row, second column times the second row. And you get here xy. And then the last one is y squared. So we can do that on the side with the FOIL. Y times x is the same as xy. And then y times y is y squared. Now what do we do with like terms? Collect them. Do you see how those two shapes are the same? It's like a rectangle and a rectangle that are the same size. So those two are the same size. You can add them up. 1xy plus 1xy is 2xy. So then you finally get x squared plus 2xy plus y squared. Now that we've done that, I want to quickly show you how it relates. So this one right here, where the length and the width are the same, expands to this. The goal of today's lesson is to actually work backwards. Weird. So let me show you. Look at this one here, 4x squared, 20x, and 25. These are perfect squares. These examples here. So I need to take the square root of each of these. What do you get when you square root 4? And square root of x squared. So it's 2x, 2x, because the length and the width have to be the same. Now what's going to go here and here to make 25? What's the square root of 25? 5 and 5. Now I want you to multiply the first term by the second term. Like remember up above it was x times y? Two different terms. Well, this one will be 2x times 5. What's 2x times 5? 10x, but then it happens how many times? That's why it doubles up to 20. Okay? It's the exact same formula as this. This was a 2, this was a 4. This was a 25, so this was a 5. And then this is twice the 10, which makes 20. Now, all to say that you don't even have to actually, like, how do you know this is a perfect square? How do you know? Like, let's try another one. This one here, the far right. How do you know that's a perfect square? Well, is 9 a perfect square? Is 4 a perfect square? Okay, so then what you can do is you can just go, okay, 3x, 3x. How did I get that? Because 3 times 3, 9. So then what would the last term be to make 4? 2 and 2. Now, how are you going to do this so it ends up being a plus? Both of these have to be positive. And then here's the double check. Like, if I do one of the outsides, I get 3x times 2 is 6x. And then if I do it here, you get 6x again. And 6x plus 6x is 12x. Do you have to do it that way? I'm just going to do it over here on the side. I'm just going to say this. You don't have to do it this way. You don't have to spot the pattern. You can do what we've always been doing. I need two numbers that multiply to... No, not 4. 36. Why 36? The first number times the last number. And then I need two numbers that add up to 12. What are two numbers that multiply to 36 and add up to 12? 6 and 6. And then that's when you know it's a perfect square. How do I know it's a perfect square? How do you know it's a perfect square? When the two, and I'll put here magic because they are kind of magical. When the two magic numbers are what? Good, the same. That's how you know. When the two perfect numbers, or when the two magic numbers are the same. That's how you know it's a perfect square. And what do I mean by square? I mean the length and the width are the same. Okay, well, we did the first one and the last one. What do they have in common, the first one and the last one? What do you notice about the middle term? They're both positive. So what happens when the middle term is negative? What happens when the middle term is negative? All you have to do is make them negative instead. Okay, so watch this. Square root of 9, 3x and 3x. Because 3x times 3x would make 9x squared. And these are easy to spot because 9 and 16 are both perfect squares. So what goes on the outside? 4 and 4. Now, in order to make this a minus in the middle, these both have to be minus. Let's double check with the FOIL. 3 by 3 makes this one. Now let's do the outer and the inner together. 3 by 4 gives negative 12x, and then look, it happens again. 3 by 4 gives negative 12x again. So you get this negative 12x twice, which makes the negative 24. So let's see if you guys can rattle off this one right now. See if you can do this one right next to it. And I'll get you started. Bracket, bracket. See if you can fill in those brackets. See if you can fill in those brackets. Got an answer? 4x and 4x? Yeah. 7 and 7. And what goes between them? Minus and minus. Good. So these ones are going to be for in the lab. These ones underneath. And just as a hint, before we jump into the lab, you have to do the GCF first. Like, look at this middle one. What do they all have a common factor of? These all could be divided by 3. So when we go into the lab, we're going to try these 4. But you have to remember to take out the GCF first, or you're going to be doing all this extra work that's going to drive you nuts. Okay? So those 4 for the lab. Now we got to do one more thing. This one's the difference of squares. So flip the page over. Now, the geometric shape for the conjugates, remember the conjugates means the two factors are the exact same, but one's plus and one is minus. So you still get a square, except one of these is a plus b, and the other one is a negative b. So let's do this together. A by a gives, that's right here. That's a squared. Now do a times negative b, negative ab. Now do positive b times a, that's ab, and then the last one is negative b times b, b squared. So what happens to this brick and this brick? Why do they cancel out? Yeah, they're the same term. One is plus 1, the other one is minus 1. They smush together for a 0 pair. A 0 pair. So you get a squared plus ab minus ab plus, minus b squared. These guys cancel, and you finish with a squared minus b squared. So that's why it's called a difference of two perfect squares. Right there, a squared minus b squared, a difference of squares. Difference means subtraction, and we have, of course, two squares. Okay, so that's why it's called difference of squares. Let's do a couple of these. X squared minus 9. If we were to do it the old way, you would be like, okay, I need two perfect numbers that multiply to negative 9. And I need two of those numbers that add to, wait a sec, there's no middle term. So if there's no middle term, it must have been 0. Can you think of two numbers that multiply to negative 9 and add to 0? Negative 3, positive 3. Negative 3, positive 3. So how could we factor this? It's a 1x squared, so 1x by 1x. A plus 3 and a negative 3. Could you guys get the 1 right next to it? How are you going to make 1x squared? How do you make a 1? There's only one way to multiply to 1. What is it? For like whole numbers. 1 times 1. So you have 1x times 1x. Now what goes on the other side? Negative 7 and positive 7. Very nice. Okay, we're going to do one more hard one. But it's actually quite nice. The one right underneath. 16x squared minus 9. Ask yourself this question. Are they both squares? Is the middle term gone? Okay, so then one of them is going to be plus, and the other one's going to be minus. And it doesn't matter what order you do that in, as long as one is plus, the other is minus. Now just think of the roots. The roots of 16. So you put 4x here and 4x here. And then what do you put for the 9? 3 and 3. I'm going to do one more for you, because sometimes you always have to check. Maybe there's a GCF first. This one students always forget. You know, maybe there's a GCF. Because if I look at this one underneath, I'm thinking to myself, oh, I see a difference. I see a square, but 50 is not a perfect square, and nor is 2. So maybe 2 and 50 have a common factor, do they? They both could be divided by. So take out that 2. What would you be left with? A squared minus 25. Now the 2 comes along for the ride. Could I factor that binomial? It's a difference of 2 perfect squares. So how am I going to make the first term? A squared would be made by A by A. And how am I going to make that 25? Negative 5 and positive 5. And that's the whole factoring of that first one, or of that last one. So always check for a GCF. Like look at this next one. What could you take out of this next one? Not only a 3, but also a 3x. Good. Okay, so let's head to the lab and we'll finish off these 2 sections.